We don't hear you, Gaston. You are muted.
Yeah, I'm muted. Okay, so another session of the GDG Cordoba. In this session, we have Renaud Tarnec. Thank you so much for being here and preparing this talk for us. So Renaud is going to be talking about Cloud Functions for Firebase, what, when, how, and how not to use it. He's going to be giving us an example, and he's going to be showing us a demo for another cool thing that we have been talking about before the stream. So thank you all for being here, and follow us in the social media. We are on Twitter, GDG Cordoba Argentina. Also, we are on LinkedIn, GDG Cordoba Arg. Also, here are the social medias. So this is all yours, Renaud. And if you want to share your presentation, we're ready to go.
Thank you very much, Gaston. Hola, Cordoba. Nice to meet you. I'm very happy to give this talk this evening to the GDG Cordoba community. I'm really happy to share knowledge with you. And before we start, I would like to thank Gaston and Luca for inviting me and for their really warm welcome. So without further ado, let's share my screen and I will show the presentation. Up. Can you confirm, Gaston, that you can see my presentation? Please. You are muted normally. Hello, Gaston? Can you just confirm you see my presentation, please?
Yes, I can see it. Can you hear me?
Yes, now I hear you.
Nice.
So you see it. Okay, thank you very much. Okay, excellent. So let's start. So the topic of this evening is Cloud Functions for Firebase. What, when, how, and how not. So before we enter into the talk itself, let me briefly introduce myself. My name is Renaud Tarnec. I'm a Google developer expert for Firebase since February of this year. I'm a full stack web-based application developer, architect, and a project manager with more than 20 years experience in IT services company. Today, I'm a freelance consultant. I have my own company, RTA Consulting, and my service offering is twofold. On one side, I do web application development exclusively in Firebase, mainly single page applications or progressive web apps. And on the other hand, I also act as an interim project manager for large companies, supporting them in the management of their application development project. I'm quite active in the Firebase developer community, and in particular on Stack Overflow, where I'm answering questions every day, and I'm also quite active on Medium. So, Firebase. What is Firebase? Firebase is just the Google's mobile and web application development platform that will help you as developer build, improve, and grow your app or the app of your customers. In a nutshell, Firebase is composed of 18 tools that can support you with web and mobile apps. So mobile apps meaning Android, iOS, and as well as Flutter. So there are three different categories when we look at the Firebase services. We have the developer tools like databases or file storage. We also have app quality tools like test lab, performance monitoring, and we have business tools that are tools like that will help you monitoring and improving your application. We have services like Google Analytics, prediction, A/B testing, cloud messaging, etc. So this evening, we are going to focus on Cloud Functions, which is in the developer tool category. But before we dive into Cloud Function into detail, let's briefly present Firebase. It's a serverless platform. What does it mean? It means that all the products and services of Firebase are hosted in the cloud. Okay, these products have backend components that are fully maintained and operated by Google in serverless mode. But that's not all. Firebase also provides client SDKs for Android, iOS, Flutter, and web, JavaScript, to interact with these backend services directly. So if you look at the figure, at the chart on the right side of the screen, we have the traditional architecture, with 3 tiers. We have the client tier, we have a middle tier, middleware tier here with an application server, and we have the third tier, which is made of databases or file system and so on. With Firebase, there is no need to establish any middleware between the application and the services. You write code in your application to directly interact with the serverless backend components offered by Firebase. It's also interesting to note that in addition to the client SDKs, Firebase also offers some different admin SDKs that allows a server to interact with the backend services. But Firebase also provides a serverless event-driven backend, which is called Cloud Functions for Firebase. So what are exactly those Cloud Functions for Firebase? First of all, it's an event-driven backend. So it means that Cloud Functions for Firebase let you automatically run backend code in response to events that are triggered by Firebase services, by HTTPS requests, or by Google Cloud Scheduler. We can divide the different triggers in 2 categories. On one hand, we have the background triggers. So a Cloud Function can be triggered by an event in a Cloud File Store database, in real-time database, in cloud storage, in Firebase authentication, in remote config, in a test lab, Google Analytics, as well as Cloud PubSub message. So these are events happening in the background and that will trigger a Cloud Function. On the other hand, we have the direct triggers, that I call them like that. They are made of a direct HTTP request, exactly like a REST API, callable Cloud Functions, which are HTTPS Cloud Functions, but dedicated to be executed from an application. They have advantage compared to the HTTPS, the pure HTTPS one. For example, all the credentials of the user are directly passed in the request. And the last direct trigger that we can consider is the schedule trigger. So with a mix of Cloud PubSub topic and Google Cloud Scheduler, it's possible to trigger a Cloud Function like we do with the cron job, for example. Okay. So event-driven. And the second main characteristic of Cloud Function is the fact that they are serverless. So they have all the characteristics of a serverless execution environment. Your code executes in a fully managed environment. So there is no need to provision any infrastructure or to worry about managing, configuring the servers, patching the server, and so on. The provisioning of resources happens automatically in response to events. So if there are a lot of users that triggers Cloud Function either directly or by interacting with the backend services that in turn triggers a Cloud Function, the platform can scale from a few invocations a day to many millions of invocations without any action from your side. And you are only billed for your function's execution time. So if we look at this diagram on the right, you see the same diagram we had in this slide. Okay, so we see the client apps interacting directly with the Firebase services. So in the front end, we have a client application, a web application, an iOS application, an Android application. And in the back end, we have the different Firebase services, and we have Cloud Functions for Firebase. And what's interesting here, and what I want to show here, is that you usually have some business logic within the client application, but with Cloud Functions, you can also have business logic, implement some business logic in the backend. The capabilities of Cloud Functions. In a nutshell, on the left part of the slide, we have the triggers. So like I said, we can trigger Cloud Function through an HTTPS request, through a call from a client application, callable cloud function, through an event in one of the Firebase services, to a pub/sub message that is published to a certain topic, as well as through a scheduler that will trigger the function according to the cron job standard way of defining triggering times. Sorry. So when a cloud function is triggered, then it will act, it will execute something. It can execute some actions in the Firebase services. For example, create a new document in the NoSQL database, delete a file in file storage, send a message through messaging, delete a user in Firebase authentication, etc. It can also call several or different APIs and services. Google Cloud APIs, like, for example, Vision API or Translate API, or third-party microservices, like Stripe for payment, SendGrid and Mailgun to send email, or it can also generate a pub/sub message that will in turn trigger another event. And last but not least, from a cloud function, you can call any URL or REST API that is exposed on the web. Okay, so we have the triggers and we have the result of the cloud function triggering. Let's look at some examples of background triggers. So with Cloud Firestore, which is the major NoSQL database offered by Firebase, we can trigger a cloud function when documents are created, updated, deleted, or the three altogether. It is a on-write trigger. So in Cloud Firestore, you probably know that that data is organized in documents that are organized in collections and sub-collections. So if you create a new document in a specific collection, you can trigger a database attached to this event. Similarly, in cloud storage, if you create a new file, a new object in a bucket, you will have the unfinalized event that will be triggered. You can also trigger a cloud function with a deletion or with an archive of an object, as well as when there is a metadata update. With authentication, you can trigger a cloud function upon user creation or user deletion. Okay, so those are three different set of examples for three different services, Firebase services. And depending on the trigger type, the cloud function will expose a number of properties of the entities that triggered the function. For example, if we write a new document in the cloud function, you will get the path of the document, as well as the set of fields of this document. And in addition, we have a context parameter that will provide information about the function's execution itself. But we will look at some example later on. Okay, so that was the what it is. It's a serverless backend that is triggered by events. Now, let's look at when should we use Cloud Function. I have two slides where I list some use cases, but actually the list is a never-ending list. You can really do a lot of things. But let's look at some example. A very classical use of Cloud Function is to synchronize nodes or documents within a database. In the NoSQL world, it's quite classical to denormalize data and to copy data to different places in such a way that your queries are very efficient. And in order to synchronize these different nodes or these different documents in the database, you can use Cloud Functions. Another use of Cloud Function is to be the glue between several Firebase services. For example, a classical use case is when you create a user in the authentication service, you will, in parallel, create a document in the Firestore database that will hold extra information for the user. Typically, this will be done by a Cloud Function that will be triggered when the user is created in the authentication service. Another very interesting use of Cloud Function is to implement complex business logic that you can only implement in a backend and not on clients because it's too complex. You can also use the Cloud Function to implement your business logic only in the backend. So you don't implement this proprietary business logic because it's, for example, an industrial secret. You don't expose it in your apps that could be reverse engineered, but you only implement it in the backend. And your apps will call the Cloud Function in the backend to have the business logic executed and to get back the result of this execution. Another very interesting use of Cloud Function is to implement the business logic only once instead of implementing it for each client platform. Okay, so instead of replicating the code in Android, iOS, and web, let's imagine that you have an app which is present on all the platforms. It's much more easier and efficient to implement it only once in one language in the backend. Another use case is to execute intensive tasks in the cloud instead of doing them in your app. In particular, you can have background tasks that you start from the app, and only when the task is executed, is finished, you send back the result to the app. You can also use Cloud Function to generate dynamic content that will be served through Firebase hosting. Another classical use is to use Cloud Function to send a notification through Firebase Cloud Messaging Service. So you see, we have already covered quite some use cases, but the list is not finished. Cloud Function is really interesting to integrate your application with third-party microservices and APIs. Like I said before, we can call Google Cloud APIs. I will show later on an application which integrate the Vision API to OCR the image of a text. So you can very easily call all the Google Cloud APIs, but you can also call third-party services like SendGrid to send emails, or Stripe to send to execute payments. And what's interesting here is that you interact with those microservices from a backend and not from an app. Okay, for example, with Stripe, at one moment in the payment flow, you have to interact with Stripe from a backend and not from an app. So if you don't use Cloud Function in this case, or one of your server with the admin SDK, you cannot implement Stripe. Cloud Function can also be used as webhooks for microservices integration. So what is a webhook? It's also known sometimes as reverse APIs. For example, with SendGrid, which is an email service, if you generate an email and you call SendGrid to send an email, SendGrid is able to detect when the recipient has opened the email or has opened the attachment to the email and so on. And you could ask SendGrid to call an HTTPS cloud function that you expose, to call this function to report back those events. So you kind of close the loop. You know that you have sent an email and you get the information through the webhook that the mail was opened by the recipient. Other example of services using webhooks is GitHub. Okay. A very interesting use of Cloud Functions is also as a workaround of some client SDKs limitation. For example, with the client SDKs, you cannot list all the collections of a file store database or all the sub-collections of a given document in file store. But with the admin SDK that we use in Cloud Function, this is possible. The same with transactions. On the client SDKs, you cannot use queries within a transaction, but on the backend with Cloud Functions, you can do that. So you can lock the entire result of a query before executing during the transaction execution. Another example of Cloud Function use is to totally bypass the security rules. Since we use the admin SDK, we have full rights on the different Firebase services, and we can totally bypass the security rules. Some applications, for example, have security rules that are totally closed. I mean, they don't allow any interaction from the application directly to the service, for example, directly to FileStore or directly to cloud storage. And you, at this moment, you can only write, read with in FileStore, for example, by going through Cloud Function. There are some use cases where it is interesting because you are in total control of the security of the access to Firebase sometimes in a more fine grain that what the security rules language allows. Very important. Those last two bullet points is the use case of managing users in the authentication service. So you can, for example, create users, you can deactivate users, you can delete, you can send email for password resetting or email to verify the email of a user. And the last one, custom claims, is very important when you want to implement role-based access rights in your application with Firebase. The way to implement such an access right strategy, role-based strategy, is through custom claims. And custom claims can only be set by a backend, either a cloud function or again a server that you control. You cannot give a specific role to a user from an application. Okay, you can only do that from the backend, and cloud functions there are really the best solution to allocate different custom claims, different roles to different users. So that was the when, a list of examples of use case for cloud function. And at the end of the presentation, there is a slide with some links, and I give some links to some documentation items where you will find even more use cases. So how do we do? We know what cloud functions can do. We know when we have to use them, but how are we going to use them? So now we are going to dive more into the code, into the technical part of the talk. First of all, let's look at the development environment. So as you probably know, cloud functions are a product of Google Cloud Platform. And Firebase has a specific, let's say, flavor of cloud function. So Google Cloud Functions support different languages. They support Node.js, Python, Go, and Java. However, if you want to use the Firebase CLI to deploy this cloud function, the command line interface, you can only target the Node.js runtime. Okay, so if you want, for example, to implement a cloud function for FileStore, the NoSQL database in Java, you have to go through either through G-Cloud, the Google Cloud CLI, or through the Google Cloud console. But you cannot do that with the Firebase CLI. This is why what we call cloud function for Firebase are the cloud functions that are deployed through the Firebase CLI. So for the specific subset of cloud functions, the one for Firebase that can only use Node.js runtime, what do we need to start developing? We need obviously a Node.js environment, version 10 or version 12. The version 8 has been recently deprecated. We need the Firebase CLI in order to deploy the function. We obviously need a Firebase project in which we will create our cloud functions. We need to initialize the Firebase SDK for cloud function. And the best to do that is to create an empty project that will contain all the dependencies and some minimal sample code. And you can choose either TypeScript or JavaScript for composing, for writing your functions. And then you need an IDE for either JavaScript or TypeScript. Let me drink a little bit. So that's the development environment. Once you have set up this environment, you start coding. So you will, in either a JavaScript file or a TypeScript TypeScript file, you will first import the Cloud Function SDK module. And then if you want to interact or if you want to access Firebase services like database, storage, authentication, you have to import the admin SDK. So you import the admin SDK and you initialize an admin app instance. And from this admin app instance, you can declare the different services, database, storage, authentication, etc. Okay. So let's look at a very simple cloud function, an HTTP endpoint. So for HTTP endpoint, any request to the endpoint results in two objects, a request and a response, and those objects are passed to the onRequest callback. So let's look at this simple code. What do? We first declare a variable called name, and this variable will look at the query that is the query that is calling this HTTP endpoint, and we'll look if there is a value name in the query string. If there is a value, it will associate this value to the name variable, to give this value to the name variable. If there is no name query string parameter, it will by default take the Cordoba value. And then we'll just send back a response to the caller with a JavaScript object, a JSON made, a JSON, which is made of just a response property, which says hola, either Cordoba or hola, the name of we have passed in the query string. Okay, so this is the code of one cloud function, and we can deploy it via the command line interface by doing Firebase deploy or Firebase deploy only functions. So let's look at this cloud function. I have deployed it. I have already deployed it in a specific project. So I'm going to call it here. So you see the URL is made of first US Central 1, which is the region where the cloud function, the Google Cloud region where the cloud function is hosted, serverless mode. Then we have the name of the Firebase project. Then we have .cloudfunction.net, and then we have the name of this HTTPS cloud function. So if I enter, it will call the backend. There is, like in any serverless service, there is a call start. We'll speak about it later. But when an instance for this cloud function has spun, is started, then the HTTPS cloud function responds with hola Cordoba. Okay, and if I add a value in the query string, so the name query string parameter, then you see the cloud function responds with hola Gaston. Okay, so that was a very simple example of an HTTP cloud function. Let's go back in presentation mode. So now we are going to look at or to cover maybe the most important part of the presentation. It's about the lifecycle management of your cloud function. This is very, very important. Managing it correctly, managing the lifecycle of your cloud function correctly, and in particular, terminating them correctly is really, really key. Okay, on Stack Overflow, for example, we can find a lot of questions of developers having problems because they don't correctly manage the lifecycle of their cloud function, and it's really a key point to look at and to remember. So why it's so important to make sure that the cloud function instance which is running your function does not shut down before the cloud function successfully reaches its terminating condition or state. So most of the Firebase operations are asynchronous. For example, if you write to the database, it's an asynchronous operation, so it takes a bit of time. And it's only when all the asynchronous work in your Cloud Function is completed that it is safe to terminate your Cloud Function. So you should write your code in such a way that it doesn't let the Cloud Function platform terminating your Cloud Function before the work is terminated, okay, or terminating it while the work is still going on. And we will see in the next slide how we do that through the code, okay. And the second reason is to avoid excessive charges from functions that run for too long or loop infinitely, okay. So, and like I said, on Stack Overflow, you have a lot of questions that are actually problems of lifecycle management. And what's quite difficult for those developers that have this kind of problem is that the code failed mysteriously. Because in some cases, if you don't correctly manage the lifecycle, in some cases, the platform will kill and clean up your Cloud Function, so the Cloud Function doesn't work. But in some other case, the platform will not immediately kill your Cloud Function, and from time to time, the Cloud Function works. And so as a developer who is debugging his code, he's really puzzled because in some cases it works, and in some other it doesn't work. So not only it's a risk because your Cloud Function may be killed at any time, but for your developer life, it's even I mean, it's really not funny when you encounter this problem. So it's really important that we go through the technique to correctly manage the lifecycle. And how do we terminate a Cloud Function? There are two cases. For HTTP triggered Cloud Function, so exactly the one we've just looked at with Hello Cordoba, you terminate the Cloud Function by sending a response. So either by calling redirect, send, or end. And for all the other Cloud Functions, for background triggered one, callable ones, schedule ones, etc., you need to either return a promise, a null value, or any object. So if I will be in Cordoba today in front of you, I will ask to the room who knows about JavaScript promises. But of course, I'm alone in front of my computer, so I don't know the percentage of participants who knows cloud promises. I will just rapidly present and explain what is a promise. In JavaScript, a promise, it's an object that represents the eventual completion or failure of an asynchronous operation and its resulting value. And a promise can have only three states. Either it is pending, so executing the business logic, fulfilled, so it's successful and you get back the resulting value, or rejected because of an error. And returning a promise in background Cloud Function, which call async method, tells the Cloud Function platform to wait until the promise is fulfilled or rejected before cleaning up the function. So to answer to the question, the previous question, which was how to correctly manage the lifecycle of a Cloud Function, the answer is quite simple. If it's HTTP trigger, you send a response. If it's a background trigger Cloud Function, which implies async methods, calls to async methods, you have to return a promise. Okay, and the platform then is monitoring this promise, if I may say it like that, and it's only when the promise is fulfilled or rejected that the platform knows that it can clean up the function. Okay, if you return something else, the platform may terminate the function immediately, resulting in this erraticus, this how did I say? Yeah, this erratic behavior. Okay, so sometimes it works, but most of the time it doesn't work, and you don't understand why. So in most of the cases, you will call several asynchronous methods in your Cloud Function. So it's important that you know how to deal with those several asynchronous calls. There are two cases. Either your calls are sequential. For example, you read a document in the database, you do some calculation on this document, you write a document, you write back a document in the database, and then you send a message, you send an email through a third-party service. These are three different asynchronous operations, and you have to chain them with the Zen method. And we will look at that into detail in one or two slides. The other case is when you need to execute the asynchronous method in a parallel way. For example, a typical example is a for each loop. Let's imagine that you query an entire file-store collection. So you get a set of file-store documents, and you want, for example, to add the value of a field. So you will have to loop over those documents to read the value of the field and to increment, to add this value to a specific variable. For that, you will use a loop, and in order to read this variable number of documents, you will use promise.all. So let's look more in detail how we are going to use these specific methods. So for the sequential calls, like I said, we have to chain them with the Zen method. We have to chain the promise returned by the asynchronous operation. So let's look at this Cloud Function. It's a file store Cloud Function, so it will be triggered when a document is created, a document in the collection named collection. We will, as soon as the document with a specific document ID is created into the collection, this Cloud Function will be triggered. And then we'll first call a specific asynchronous operation. And we will use the Zen method to get the result of this asynchronous operation. And we will, based on this result, we will do something else which is asynchronous. And then we will return the promise returned by this asynchronous operation. And we will again use Zen, the Zen method, that will give the new result when the promise returned by this asynchronous operation, when this promise is fulfilled. In the Zen, we get the new result, and again, we can call a third asynchronous operation. And you see, what's important here, it's to note that first, the Zen and catch method return promises. So it means that we can chain them. So we can here, we can here have a return, because this asynchronous operation returns a promise that is returned through Zen, which return a promise. This one returns also a promise, and so on and so on. So at the end, here, this returns a promise, and it's exactly what the Cloud Function platform is looking at, is waiting to confirm that this Cloud Function is currently under execution. Okay, so as soon as the promise return here is not fulfilled or rejected, the Cloud Function will let the Cloud Function platform will let this Cloud Function instance running. So let's look at a real example. Let's try to sequentially call two asynchronous file store methods in another Cloud Function. So what are we going to do here? We are here in a storage triggered Cloud Function with the onFinalized event. So if you remember when I presented the triggers in detail, the onFinalized trigger is triggered when you upload an object in a file storage bucket. So what are we going to do? We are going to, through the object variable, we are going to define the bucket and the file, and we are defining a configuration for a signed URL. So what are we going to do? We are going to upload a file to cloud storage, and upon when the upload is finished, we want to generate a signed URL for this file and to write this signed URL into a file store document. So what do? Again, we define the bucket, the file, and we define the options for the signed URL. So it will be a signed URL for read with an expiration date. And then we call the get signed URL, which is an asynchronous operation, an asynchronous method, which returns a promise. Okay, we pass the configuration, and then we call the then method. We get a data response from the get signed URL. We extract the URL. It's the first element of the data array. And then with this URL, we call the admin SDK with FileStore. And in a specific collection called signed URLs, we will add a FileStore document with two fields. The first field is the file name. So we take the name of the object that was uploaded. And the second field is called signed URL, and we assign to this field the URL that we just got through this asynchronous method. Okay, so you see here, I have return and return. So I'm correctly returning the entire promise chain. So let's try this cloud function. So what I'm going to do, I'm going to open the Firebase console. So here I'm in storage, and I'm going to upload a file. So I will choose an image here. Okay, I upload the file, and then I will switch to the Cloud File Store part of the Firebase console. So I could have detailed a little bit the Firebase console. So the Firebase console, you see on the left part of the screen, we have a vertical menu, and we have the different services that we use to build applications. So previously I was in the storage part of the console, and now I switch to the Cloud File Store part. And if I refresh, I should normally see a new collection called signed URL. And here I have a new document which was assigned automatically assigned an ID. And in this document, I found the two fields I've just detailed. And if I take the value of the signed URL, I copy this value, and let's try. I get the image that I've just uploaded in cloud storage. Okay, so that was an example of a background triggered cloud function that interact with two different services, two different Firebase services, cloud storage on one hand and Cloud File Store on the other hand. Okay, and what we can do, we can switch to a third part of the Firebase console, which is functions. And here, first, we see the three different functions that are deployed in our project. And we can also have a look at the log, and we will see the execution of this cloud function. Okay, you see here in Belgium, it is 11:43. So let's go back to the slide. And let's now have a look at managing several asynchronous calls in parallel. So here we were sequential. We call this get signed URL, and only when we get the result of this call, we call the add asynchronous method. So we are calling those different asynchronous method in a sequential way. But like I said, sometimes you want to call different asynchronous method in parallel. So let's look at this cloud function. I will first switch to the File Store console because it will use this collection. This collection is called countries, and we have a set of documents in countries. which have an ID, which is the ISO code of a country. So in case of Argentina, the ISO code is AR. The name, the official name is Argentine Republic, and the capital city is Buenos Aires. Then we have Belgium, Denmark, and so on. So, okay, so we have a list of countries. And what we are going to do in this cloud function, we will first trigger it by an HTTPS call. Okay, we could have triggered it by any other way. It's just an example. I could have very well triggered it by creating another file store document somewhere else in the database. But I will trigger it with an HTTP call. So we first declare an array, which is called promise. And then we fetch the country collection with the get asynchronous method. When we get the result of this query, we get a query snapshot, which is a collection of document snapshots, and we will loop on this collection of snapshot document. Okay, obviously, we don't know upfront the number of documents we have in this collection, so we cannot sequentially change the promises. We have to use a for each to loop over a variable number of documents, and for each document, we will assign the value of capital city to a capital city variable, the name of the country to a country variable, and we will push to the promises array, we will push an asynchronous, a call to an asynchronous method. So it is a method that returns a promise. So actually we are pushing promises in this promises array, hence the name of this array. So we push database collection city, doc capital city set with a JavaScript object. So what this line is going to do, it is going in a collection named cities, it's going to create a document with an ID, with the ID having the value of capital city, and it will assign two fields to this document. The first field will be called country, and we take the value of the country. And the second one will be called capital city, and we will always pass the value true. Okay. So for each document we have, here, we will create in a new collection a corresponding document which will have the name of the city as key, and which will have a field capital city equal true on one hand, and the name of the country. And when I have populated this promises array, I call this specific method promise.all, and I pass the promises array. And what do I get? So this method promise.all returns a promise, so I can use the then method. I get the result, which is an array. In our case, since the set method returns void, we get an array of non-null promises containing void. But what's important to note when you use promise.all is that this array has the same size than the promises array we passed to promise.all, and also has the same order. Okay, so in this case, since we get void, the fact that there is the same order doesn't matter, because we are not going to use the result. But in some other cases, it's very interesting that you know that you have the same order. Okay, and what are we going to do when we get this result? We are going to send a response to our HTTP caller, the process that is calling this cloud function. We are sending a response, which is an object, a result with the value of the length of the array city documents created. Okay, I hope I'm clear. So let's now call this cloud function, where it is. It's here. Okay, so again, it's an HTTP cloud function. So I call it with this URL. So I get the expected response, which is 10 city documents have been created. Let's verify that. Now you see that we have a new collection called city. And for each document we had in countries, I have created, the Cloud Function has created a document with the name of the city as the ID and 2 fields, the name of the country and this constant true for capital city. Okay, so this is an example, but what's important to note, it's the way we deal with these parallel calls to some asynchronous functions. Okay, so by doing that here, we correctly return a promise when all the work, the asynchronous work for the 10 different documents, when all this work is done, it's only at this moment that we return a promise that we catch with the then method. So if you look really thoroughly to this code, you will see that here I don't have any return. While before, when I was working with a background triggered Cloud Function, I have the return, because for a background triggered Cloud Function, I have to return a promise. While for an HTTP request, a Cloud Function, I need to terminate this Cloud Function by sending back a response. But what's important, and why do I work with promise here, is that before sending back this result, I have to wait that all the asynchronous operations are completed before sending back the response. This is why I use the promise all method to execute all those methods in parallel. And only when I get the result through the then method, I know that it is safe to send back a response, which result in a response sent back to the caller, obviously, but as well as it will indicate to the Cloud Function platform that it can clean up this specific Cloud Function. A last point on this is that I have shown, I have explained all these important elements with the then the use of the then method, but you have to know that there is a much more modern and a much more cleaner way of dealing with asynchronous method in JavaScript, in particular with ECMAScript 2017, is to use the async await keywords. And then your promise-based can be written in a much more cleaner style, and even more important, it's very similar to synchronous code. So let's look rapidly at how this Cloud Function, which is a background Cloud Function, so we return the chain of promise, okay? Return, then return. How are we going to write that in the async await mode? First of all, we have to declare the callback function as async, okay? And when we execute asynchronous function, we use the await keyword in such a way that the code, the execution, is stopped here until the asynchronous method is done and the promise returned by this asynchronous method is fulfilled. Okay, and so you see by using async await, I have a much more clear code where I declare a variable country code, then I declare a document snapshot variable, which is populated through an asynchronous method, but it's done in one line, while here I have to use the then method. And then again, if I have another asynchronous method to call, so here what I'm doing actually, I'm getting the value of a country code. Based on this country code, I'm getting a document in a Firebase collection, and based on this document, I am updating another document, okay, with 2 fields. So the update method is an asynchronous one, and here in this then version, we do return. We return the promise returned by the update method, but here we just call await. And when this update method is done, we can safely return. In this example, we return null. And then similarly to what we have here, the Cloud Function Platform knows exactly when to clean or not, to clean up or not clean up the Cloud Function. And all the examples we've just seen were made of Firebase asynchronous method, but it is exactly the same with, for example, third parties APIs, SDKs that you can call from a Cloud Function. For example, if I integrate a Cloud Function with Stripe, you see here I'm going to call a specific a specific Stripe asynchronous method called payment intents. I use await. So I wait that this method, the promise returned by this method, resolve, is fulfilled before continuing the execution. The same for Mailgun. Here I use a specific method send mail, the method of SMTP transport, and similarly I use the await to wait again that the promise is fulfilled before proceeding further. Okay. So that was a big part of the presentation. And again, if you only want to remember something in this presentation, it's really this part about lifecycle management and correctly terminating your function and correctly writing your code in such a way that you either send back a response in the case of HTTP function, or you deal with promises in case of background cloud functions. So just to have a bit of fun, let's look at a web app, as a demo of a web app that is called Travel Translator. You can take your smartphone, you can flash the QR code, and it will open in your browser a web app, okay, at this URL. And what is this web app about? So again, it's a demo application. The idea is to, it's called Travel Translator. It will, if you take a picture of a text, for example, if you have a book in Spanish close to your table or close to your computer, you can take a book, you can open a page, and you can make a picture of this page, and the application will first OCR, so do the optical character recognition of the text, and then get the result of the OCR as a text, and then we'll translate this text in English. Okay, so I'm going to show it through my web browser from my laptop, but again, you can very well use your smartphone and give a try. And after the demo, I will switch to a Medium article I have written, which explain all the architecture of this application, and in particular shows how easy it is by mixing the different Firebase services, how it is easy to write such an application in only 25 lines of code. So let's switch to the application. I hope you had time to for the ones that want to try it, you had the time to either flash the QR code or enter the URL. So in my case, I'm going to, In my case, I'm going to use this text, which is in Italian. And here is the Travel Translator application. So here in my laptop browser, it will open a file window, but in a smartphone, it will propose you to use the camera of your smartphone, and you can very well take a picture of a text. So I will upload this text, and then you see here we have a spinner. So there is a cold start, and here I get the result. So the original language was detected as Italian, and I have the translation in English. So what I propose now is to look at this article and to explain you, to present you the architecture of this application. Okay, so the application is made of five or six main components. First, we have a web application, which is the front end, the application you have just seen, or that you are maybe seeing in your own smartphone. Okay, this is a web application. It's the front end, and this front end will interact with a set of Firebase services which are in the backend. So first of all, we have a cloud storage bucket. Then we have a cloud Firestore database. We have several cloud functions. We have the Cloud Vision API, and we have a Firebase extension. Firebase extension is predefined parameterizable snippets of code, which are actually based on Cloud Function. So I will now detail the way all the different events are chained, are orchestrated, and then later on I will rapidly look at the code. So what happens when you take a picture of an image in your smartphone, with your smartphone in this web app? The file is uploaded to cloud storage. Okay. At this moment, cloud storage triggers a cloud function, and this cloud function will take the file we have just uploaded and will send it to Cloud Vision API to get the OCR of this image. So Cloud Vision API will OCR the image, optical character recognition, and will send back as a result the translation of the text in the image as well as the original language. At this moment, we write the data, the text of the translation and the original language. We write that to a specific Cloud Firestore document. And as soon as this Cloud Firestore document is created, the Firebase extension, which is behind the scene a cloud function, is triggered, and this Firebase extension will translate the original text into English and will write back the result of this translation to the Cloud Firestore document. And the web application, at the beginning, and I should have said it at the beginning, in addition to uploading the file to cloud storage, the web app set up a listener to the to-be-created Firestore document and watch this document. And as soon as the listener detects that the field with the translation is populated, so the result of the Firebase extension translation, as soon as the web app detects that this field is populated, it displays the result. Okay. So I will now dive into the code. We have three main parts. We have the code for the web app, we have the code for the cloud function, and we have the configuration for the Firebase extension. Okay, so again, the Firebase extension is just a package around a cloud function, and we could have very well shown here the translate Google Cloud Translate API, similarly to the way we have shown the Cloud Vision API. Okay, this extension uses the Translate API. So let's first look at how this extension is configured. So we say that this extension should be executed in the Iowa region. It should translate the language to English, but we could have separate languages here, separated with a comma. It will it will be triggered when there is a new document added to the OCR translations collection, file store collection, and it will take the value of the input field. So the input field will contain the text to be translated. The extension, the function in the backend will translate this the text that is in the input field and will write it into the translated field. Okay, so here we are working in the FileStore NoSQL database. Okay, this extension is looking for the creation of a new document, and again, it is a cloud function, which is a standard cloud function, which is triggered by the creation of a FileStore document. So that was the extension. Now let's look at what we have in the application. So in the application, like I explained, we here it's very it's a simple HTML. So the application itself is done with Vue.js, but I'm not going to go through the entire code of the Vue.js component. I show here just a simple JavaScript that does exactly the same thing. So in a nutshell, we are going to upload a file to file storage. And before uploading this file, we define a file store document, and we ask by using the doc method, we create the reference of a file store document. So the document is not already created, but we already have the reference of this document. And with this reference, we can get the ID of this document. And what we do, we use the ID of this file store document to create the name of the file we are going to upload. Okay. So based on this name, we define the reference in cloud storage for this file. Okay, so we call Firebase storage, and we call the ref method, and we pass to this ref method a file name, a reference name made of two parts. First, this is a folder, then we have a slash, and then we have the name of the file we are going to upload. And remember, this name again actually has the same, it's the same value than the file store document. And then with this file reference, storage, cloud storage file reference, we upload the file by using the put method, which is, oh, what a surprise, it's an asynchronous operation. So of course, we are going to use the then method. And when the asynchronous operation of file uploading is done, then we set the file store document listener on this document reference. Okay, so and in this listener, we will only execute some business logic when the document exists first, and secondly, the document has a field translated. Okay, so remember the extension. As soon as we get the result of the OCR in the original language, in the case of my example, it was in Italian, the cloud function writes the Italian text in the input field. The Firebase extension is triggered, executes the translation, and writes back the result in the translated field. And then the listener we've just seen will be triggered. Okay, so the listener is triggered when there is a field called translated in this file store document. Okay, so now let's look at the third part of the architecture, which is the cloud function. And the cloud function is here. And so what do we do? Like we said, it is a cloud function that is a background triggered one, and that is triggered when there is a new object created in cloud storage. This new object is a picture that we have just taken of this text in any language. So when this object is uploaded to cloud storage, again, we get the file path, we get the content type, we extract the file store document ID. So this is why it was interesting to use the file store document ID as the file name, because we can easily get this ID. And then we call. So what do? yeah, this is just a test. If it's not an image, we return null, meaning that we stop the cloud function. But if it is an image, we will use the Vision API. So I will not enter into detail here, but we in 3 lines, we get the result of the OCR. Okay, so we call the text detection method on a Vision client, passing the address of this cloud storage object, and the Vision API returns a result object which contains a text annotation object. And from this object, I can get the description, which is actually the text itself, and I can get the original language. And when I have those two values, we write to this OCR translation collection a document, a file store document with the ID that we have defined in the application, and we write this document with those two fields, okay, and also with the file path, and then terminate the cloud function. So what we've just seen here is all this process here. The cloud function is triggered when the file is uploaded to cloud storage. The cloud function sends the file to Cloud Vision API, get back the text from the OCR, and write the cloud file store document. And like we said before, the Firebase extension is triggered, makes the translation, writes back the translation, and then at this moment, the listener in the application is triggered and displays the original language as well as the translate text. Okay, so why I wanted to show you this application, because I think it's a very good example of how we can mix and match the different Firebase services, and how we can, with the different listener and triggers from the front end as well as from the back end, how we can orchestrate all these different processes in such a way that at the end we get in our browser, in our web browser, the result of the translation. And I'm sure you have noted that we needed only like 25 lines of code, okay? Just by using the different services and mixing them correctly, it's very, very easy to create something which is quite, quite powerful at the end, okay? So I hope you enjoy this demo. I encourage you to read this article. The URL is in the slide, and you will get the slide, so you can later on take the time to read that, to fully read this article. Let me drink a bit of water. Okay, so let's continue with the presentation. So we have seen how we have to write a cloud function and how important it is to correctly manage the lifecycle. So now let's look at some other topics about the how. Okay. First, about the environment variables. So you can store and retrieve some environment variables for your project through the Cloud Functions built-in environment configuration system. Why it is interesting? It is very interesting in particular when you have several environments like development, test, production, and it's not when you must work with different environment, and this is a way to use different variables, different values depending on the environment. Okay. It makes your code much more portable, okay, like I've just said, and it allows to switch between different environments, or also to store some module configuration, for example, APIs key, etc., etc. For example, if you are developing an application for a customer, you may have your own SendGrid or Stripe key, and your customer has its own keys. And then with this environment variable, it's very easy to manage that correctly. So it's very easy. You have to use the CLI. You can set some key value pairs, okay, some service dot key equal key, some service dot ID equal ID, etc. And you can also, so this is to set the configuration, the environment variables, and the get is to get the environment variables that are currently set, and this will output a JSON. And within the Cloud Function itself, you just have to call function.config.the key of the environment variable, and you will get the value. You can also set and get the value through the GCP console. Secondly, configuration and runtime options. So you can deploy a Cloud Function in different regions. You will find in the Cloud Function documentation all the available regions, and you can very well, by default, your Cloud Function will be deployed to US Central 1, but you can easily change that by calling the region method here and passing to this method the name of the desired region. And you can very well have the same Cloud Function deployed in multiple regions. Okay. The runtime options, there are two parameters that you can modify. First, the timeout of the function. The maximum value is 9 minutes. Okay. And the memory, you can go up to 2 gigabytes. And you can also do that through the Google Cloud Platform console, because like I said before, Cloud Functions for Firebase are actually Google Cloud Functions. So you can look at them through the Firebase console, but you can also look at them through the Google Cloud console. And you can also modify the different parameters or the different configuration or runtime options through this console. Monitoring and testing, an important part. So to monitor, you can first write some logs, either by using the well-known console log or console error, or by using the Stackdriver logging library for Node.js. You can view the logs in the Firebase console, like we seen before, in the Firebase CLI, through Stackdriver logging user interface, as well as through the Google Cloud Platform console. And you can emit errors to Stackdriver error reporting and view those errors in the Stackdriver error reporting in the GCP console. So this is not in the Firebase console, but in the GCP console. To test your Cloud Function, the CLI includes an emulator, which can emulate the following functions: type HTTPS, callable, and Cloud Firestore functions. But more function will be added in the future, without doubt. And the emulator suite includes multiple emulators, and which enable testing of cross-product interaction. So what it means that you can locally emulate your Cloud Function, and if your Cloud Function interact with Firestore, like we have seen in the examples, writing or reading some documents, you can also use an emulator of Cloud Firestore to see the result of your Cloud Function execution in the Cloud Function emulator. And also, because we could discuss for hours here, so these are some important points that I could not tackle because of the time constraint, but I provide you some links. So for cold start, like you probably know, with any serverless service, which will ramp up and ramp down, and which will be activated only when some users are calling the service. It means that sometimes the service is totally stopped. So it means that when you want to restart an instance of a Cloud Function, there is a certain starting time, which we call call start, and you have to know how to deal with that. And there are some techniques to reduce, to minimize the call start. And in particular, this article and this video are very important, very interesting for minimizing the cold start time. Also interesting is to look how you have to manage the instance resources, how to retry asynchronous functions on failure, how to use TypeScript, because using JavaScript and TypeScript is a big difference. Also, what we could have covered is the difference between HTTP and callable cloud functions, but you will find that in the documentation if you need to get more details on this point. And a last point is when you call non-Google APIs from a cloud function. So remember APIs or URL. Remember I said that you could call any URL, any REST API exposed on the web. If it's not a Google API, you will need to be under the Blaze pricing plan. Okay, so it's a plan where you have to enter the credit cards details in order to choose this plan. But in any case, with the deprecation of Node.js version 8, now to use Node version 10, you also need to be on Blaze pricing plan, and you also need to enter credit card detail. It doesn't mean that your credit card money will be taken from your credit card, because there are some generous free tiers, but you need to enter those details. Okay. Why I mention this point is because on Stack Overflow, in particular, we find a lot of cases where developers don't understand why the cloud function doesn't work. In some cases, it is because it calls a non-Google API service. So we have looked at how we should develop a cloud function. Let's look now at some how not. So some errors, some classical errors or classical anti-patterns. So the first one is quite clear, is it's when you don't do what we have explained before, when you don't correctly manage the life cycle of your cloud function. So in particular, when you return before work completion. A very good example, it's when you want to do some heavy work. Let's imagine that you have a complex processing, for example, a set of images that you want to resize or etc. And it's a long operation, and you are triggering a cloud function, an HTTPS cloud function, and here the developer start the asynchronous work here, okay, which is a heavy work asynchronous, send back a response, but before doing that, the developer sends back the response with a result saying heavy work started. So actually, what's going to happen, the cloud function is going to terminate here, because remember, we are in an HTTPS cloud function, we terminate it by sending back a response. So the developer wanted to acknowledge the fact that the work has started, but he's doing a mistake, because this asynchronous work will be stopped as soon as the cloud function platform will detect the fact that the response was sent and will kill the cloud function. So in this case, what you should do, you should use pub/sub. So you should publish a message that will in turn trigger a cloud function that will do the heavy work. So I will not enter into detail, but we create a new pub/sub client. We have a specific topic, which is heavy work, okay, and we pass in the message, we pass the file name of this big image that we want to process, which will be a heavy operation, and then we publish to this topic, we publish a message, and then we know that upon message publication, we will trigger a cloud function that will take this image and that will execute the heavy work. When we have done that, we know that we can safely send back the response to our client saying, yeah, the heavy work has started. Okay, and here it's correct because the asynchronous work is the publication of the pub/sub message. This is done very rapidly, and so you can nearly immediately send back a response to the customer. And then behind the scene, the heavy work will be executed. And if you want later on, when the heavy work is completed, if you want to acknowledge or to inform the user that the work is completed, you have a lot of possibilities. You can send a notification, you can send an email, or you can even write to a Firestore document that you watch from your app. Okay, so you have different, so you can warn the user that, okay, the result of this heavy operation is available, and you give a URL or etc. Okay. Second error is to forget to return the chain and to return the promises. So again, here some examples. Here the developer correctly returns the promise returned by the update method, but forget to return the entire chain. Here the developer returns the chain at the top of the chain, but doesn't return in the then method, doesn't return the asynchronous, the promise returned by the asynchronous update method. Okay, these errors are quite classical, so watch out, be aware, look at your code and double check that you are correctly returning and chaining the promises. Another classical problem is to create an infinite loop. Be careful because, I mean, in this case, you will, I mean, an infinite loop occurs when the result of your cloud function retriggers the same cloud function. A typical example is when you, for example, here we trigger the cloud function when a document is updated, and within this cloud function we update this document. So obviously the cloud function will be triggered and triggered and triggered. So how do we do that? We have with the onUpdate trigger, we have a change object that allows us to get the state of the document before and after the update. So we are able, for example, here to check that the status field was not modified. If the status field was not modified, then we can update the document. But if sorry, I make a mistake in my explanation. If the status field is different before and after, we can update the status field. But if the status field is the same before and after, then we just return null and we stop the execution of the cloud function. And also, you should not use callbacks instead of promises. So there are some asynchronous libraries with asynchronous methods that doesn't offer promise mode and that only work with callbacks. So you should not use callbacks in your cloud function. And if the library you want to use doesn't offer a promise flavor or promise mode, then you should wrap the callback into a new promise. Another classical error is to, in the cloud function, to set a listener instead of only reading once the database. It's a bit of nonsense to set up a listener in a cloud function, which is a short life execution, and you should only read once. You fetch the database, you get the data, you do whatever you want with the data, but there is no interest of setting a listener because the cloud function after the execution will just be killed. You should take care of when you want to execute very long operation because the timeout is 9 minutes. So if you have some work, some processes that need a longer time for execution, then you should choose another approach. For example, App Engine. Another error is to forget to delete the temp files for cloud storage. You will find in the links I have put in the slide, the above slide, you will find some more information on that. And also a classical error is to use the await keyword in a for each loop, because the for each loop doesn't return anything. And so you end with an error. And so the way of doing that is to use promise all, and to push the different within your for each loop. You push the promises to an array, and then you await promise.all. And with that, we have reached the end of the presentation. The next slide is just a list of very interesting links that I encourage you to read. You will find more use cases. You will find the Firebase sample library. So it's a set of, I don't know how many, maybe 20 or 30 different cloud functions implementing different use cases that were done by the Firebase team. And really, it's a must read. You should really dive into this. It's a GitHub repository, and it's really, if you want to progress in cloud function, take some time to look at it, analyze it, and it will really help you. You have also the official video series and the tip and tricks doc, which are quite interesting. And with that, we have reached the end of my presentation. So I would like to thank you. We'll open a question and answer session, but do not hesitate to connect with me. I will be really happy. And I hope you have enjoyed my presentation. Gaston,
Wow.
I give you back the floor.
Solid presentation. Congratulations. It was really awesome. We have a bunch of questions as well. And if you feel ready, we can start.
Give me a few seconds.
Okay.
I'll drink a little
So
bit.
the first question is from Lucas Novile. It says, which other payment gateways we can use with Firebase?
Any gateway that expose an API. Like I said, you can call any API. So personally, I don't know any other ones than Stripe. I try to remember, but no. But as soon as you have you can interact with standard APIs, you can use Cloud Functions.
Nice. And he has another question about the same topic. And what's the level of effort to integrate a new payment gateway?
Oh, Stripe is very simple, and it's a matter of I don't know, if you start to masterize a little bit Cloud Function in 1 hour, you are done. But you should note that. Let's switch to. I will share my screen again. I don't know. You see my screen? Hopla. Do you see it correctly?
Excellent.
Okay. You have to know that recently, at the end of July, a new extension. 2 new extensions have been. Where is the extension? Here. 2 new extensions have been deployed, and they are Stripe extensions. So let me look at it here. Where do I have the? The documentation here. I think I should go to product, and product I should go to at the bottom to Firebase extension. And here, if you look at the full list of extension, you see that we have two extensions with Stripe. So, like I said, extensions. I will just read the doc. Extension are pre-packaged solution. Okay, so you just have to configure like we have seen in the travel translator application. So here you will configure the extension in order to trigger a payment based on some file store documents. And I take the opportunity we are looking at extension to tell you that all the codes of those extensions is available. If I look at C details, if I look here at source code for each extension, you will find the code of the extension. And similarly to the samples I mentioned before, it's very interesting to look at this code, okay? Because again, it's done by the Firebase team, so it's a state-of-the-art function code, okay? So do not hesitate to dive into the code of each of those extensions, okay? So the answer is it's quite easy in a cloud function to interact with Stripe, okay? I think when I started doing it, the problems I encountered, the most important problems I encountered was more to find the exact API key to use and so on, because it's quite straightforward. The documentation of Stripe is really good. And now, in addition, there are two pre-packaged solutions to execute payments.
Excellent. Excellent. That extension functions are really, really nice. Andres Soler asking, is there a way to run cloud functions locally without deploying?
Yeah, with the emulator. I've just mentioned the emulator. So please go to the documentation, and if you go to cloud function, here, test function, and you have everything you need, okay, to run function locally, to unit test function, and so on. I didn't enter into detail because the presentation will have taken 3 or 4 hours, but you have everything in the documentation.
Excellent. So let's see. There's a release night meeting. Alex is waving his hands.
Thank you.
Arnaldo is asking, can we call a REST API with cloud functions and host it in Firebase hosting?
Yeah. Again, I will point you to the documentation. You remember when I was listing the different use cases, I said that you could use cloud function to generate content that will be served by Firebase hosting. So for that, you have to go here where it is. To be honest, I rarely use that. Where it is. It is probably in hosting. If I don't find it in 2 seconds, I will answer later on. So actually, you use cloud functions to generate content that are exposed through hosting. So here, if I go to hosting, where it is. Yeah, here, serve dynamic content and host microservices. Okay, use cloud function for Firebase. Okay, so again, the documentation is very good and very complete, and this is valid for the entire set of Firebase services. Look at the documentation, take time to dive into the documentation. It's really, really, really good. And you will, it takes you by the hand and step by step explain you how to do. So here, it explains how you can link Firebase hosting with cloud function. And when you call a specific URL in Firebase hosting, it will trigger a cloud function, fetch some data in the database, for example, and send back the result as an HTML page. Okay?
Awesome. So we have a bunch of questions here. Is there any chance to create a cron job in Firebase using cloud functions? Is an easy way to implement that? And there are any specific tips to do that?
So I'm not sure what you mean by creating a cron job in Firebase. So if you mean having a cron job that will trigger a cloud function regularly, for example, every day or every end of the month, it is actually the scheduled trigger type. So again, I will go back to the documentation. So you have to go to cloud functions. And here, you remember we have 2 types of triggers. We have the background trigger and we have the direct trigger. And here, you will see how we can schedule a function. So it's a mix of a pub sub topic together with cloud scheduler. And you are really able to, with the standard cron job syntax, to schedule your cloud function. Okay. So here, for example, this cloud function will run every day at 11:05 a.m. So I hope I correctly understood the question. But if you want to trigger on a regular way a cloud function, it's it's how you have to do it.
There is another question from Lucas. It says, Firebase and cryptocurrency. Do you think we can automate buying bitcoins with cloud functions? Is that
I,
even possible?
I don't know. I never heard about that. But again, since you can call any API, probably you can, but I cannot answer I cannot
Nice.
answer this one.
So here is another question from Juan Cruz. It says, do cloud functions operation in Firestore or storage count for billing?
Yeah. So obviously it count for the billing of the cloud function on one hand, okay? But any document that you read, write, delete, or any file that you read or upload from a cloud function count as for the billing of Firestore or storage or for the service. Okay, so the fact that you are writing a Firestore document from a cloud function or from a client makes no difference in terms of billing.
Excellent. So Ramiro asks, how can we test the cloud functions lifecycle?
What Ramiro
Yeah, that's a
means
tricky
exactly by
question.
testing the life cycle. You can test the cloud function. Like I said, there is an emulator, or you can also deploy it and try it. To test the life cycle, I'm not sure to understand. It's more to take extra care to correctly manage the life cycle of the cloud function. Okay. Again, the documentation, go through the documentation and what I've just explained with the use of promises and so on. You will find it again, the documentation. It's very well explained. So I hope I answer. If Ramiro wanted to ask something else, just shoot a new question.
So Franco asks, hi there, wondering that other Firebase extensions are worth mentioning.
I have to look at them. I have to admit that I have used some of them, but not all of them. So we look at them all together, and if I see some, what do we have? To resize images, export collection to BigQuery, trigger email. This one is quite interesting, even if sending an email is really not difficult. But here you have it pre-packaged. So you just have to configure the file store collection in which you create a document, and this document, in this document, you put the to or the CC or the BCC field, you put the simple text content or the HTML content, and then it will send an email. And I can tell you that Gaston has written a very good article on that on our Medium publication, which is called the Firebase Tip and Tricks in Medium. So have a look at this article from Gaston and follow us on Medium. What do we have? Delete user data is quite interesting, in particular in Europe for the GDPR constraint. You know, when you have to clean up if you delete the data of a user somewhere in your database or in your infrastructure, the regulation obliges you to delete it everywhere. So this one is quite interesting. Another one very interesting, it is a distributed counter. So in NoSQL mode, you cannot do like you do in SQL, where you call the count keyword that will count the number of records corresponding to an SQL query. In a NoSQL world, it's not possible to have this kind of aggregation method. So if you want to count the number of documents in the collection, the first solution to do that is to query the entire collection. But obviously, if you have a lot of documents, it will be a nightmare in terms of pricing and in terms of response time. Okay, so what we can do in NoSQL databases, and in particular in Firestore as well as in the real-time database, it's to maintain some counters in specific collections or specific nodes, and update this counter each time a document is created or deleted. And the best candidate to do that is a cloud function. And this extension again, will do that. And if you want to have more information about the concept of distributed counter, there is a very interesting item in the doc. So it's not in the Cloud Function documentation, but it is in the FileStore documentation. So the NoSQL databases in solutions here, distributed counters. It's also a very interesting article, very interesting documentation item to go through, and it shows how it creates a different. It kind of distributes the counter in different file store documents in such a way that you don't encounter the limit of one write per second in file store. So this extension, in my opinion, is also very interesting, and I think we have covered the most interesting ones.
Excellent. So we have the last question from Manu. He said, hello, I have a question. Is using a cloud function a good way to delete all documents from a collection?
Yeah, now it depends if it's a one-time operation or if it's something that happens regularly. Okay, if it's a one-time operation, you could very well go through the file store console. But if it's something that happens regularly, indeed, it's very good to use a cloud function instead of, for example, triggering this deletion from the client. You will have to wait for the execution of the deletion to be completed before indicated in your application that the action is done. You could very well trigger a background cloud function, and which will delete all the documents from a collection. And again, there is also an article on that because there are some specific technique to do that. Let me check here in solution. Yeah, here you have an example. Delete data with the callable cloud function. And it's also a very interesting article because there is it works by batches, if I'm not mistaken. So have a look at this article, and you will have all the details. So you see, it's indeed a very good use case for a cloud function.
So thank you so much, Renaud. I think that it was the last question. So thank you so much for this solid presentation, and thank you all the public that has assisted to this awesome talk. Hope to see you in the next episode. So we keep in contact to do so.
Thank you very much, Gaston. Thanks to all the participants. I hope you have enjoyed and that you have learned something today. And use cloud functions. It's a very, very good product. And together with Firebase, it's an awesome. It makes an awesome platform. So all the best for your Firebase developments. And thanks again for welcoming me this evening. Bye bye.
Thank you. Bye bye.
Everyone.